The process of digestion of plant samples begins with air drying the sample, after which the samples will be weighed. 1 gram of each samples will be weighed, and the video of weighing that happened earlier on, which I posted few days ago. What you see me doing here is that we are trying to transfer all the samples in a beaker for the process of digestion. Each of the sample had already been weighed, which is 1 gram, and the Quiriggia method is used, which is the mixture of HNO3 and HCl in ratio 3:1. Of course, this will be mixed, and after which is going to be placed on fire for the nitrogenous component to be able to burn out. This is nitric acid, which is HNO3, and this is hydrochloric acid, which is HCl, concentrated one. This is HANALA. Now, this acid will be used in their concentrated form in ratio 3:1, like I have said earlier on. So we are using 15 ml of HNO3 with 5 ml of HCl, and that is ratio 3:1. And so, because of the condition of the laboratory, the two acids will not be mixed in the same environment in order to avoid the combustion of each of the two. So it has to be done in an open place so that the smoke will be able to go out. And at times we do it in a fumes comboard, which, if not done through that, cannot even affect the result. This is the addition of the HCl, which is 5 ml of HCl to 15 ml of HNO3, ratio 3:1, as I have said. And just like I've said, the two acids cannot be mixed inside the lab because it's going to create a whole lot of smoke in the lab. So we have to bring it outside. And the addition of this acid is meant for the heavy metals to be extracted out of the samples, because the samples you're seeing here, the soil, the shoots, and the root system of the plant sample. This is the boiling. The essence of this boiling is to allow the nitrogenous poisonous component to escape from the mixture. Of course, you see the brown flames turning to white, and when you start seeing the white flames, you know that the sample had already been digested. The samples that we did here is almost 200 samples, which we did batch by batch, which is 40. So what we took out the other time was just 40 samples out of almost 200 samples. So that's why we try to do it batch by batch. And of course, after the boiling and all the nitrogenous poisonous gas has escaped, that is what is going to prove to us that the sample had been digested. Then the following thing is filtration. We are going to filter so that the residue will go with the filter paper and the filtrate will go for the AAS. This process is just the process that will make the heavy metals to be visible from the lead, to be able to, for AAS process to be able to analyze the amount of each heavy metals that is present in all the samples. But if the samples did not go through the digestion process, there is no how the heavy metals can be visible or can be readable. So this is, let me call it the very last stage of digestion, which is filtration. When we filter, then we'll keep in a sample bottle. Each of the samples will be tagged. After tagging, then it's going to be taken to the lab again for the elemental analysis, which is going to be done from another machine. Of course, each heavy metals that will be analyzed from each samples had already been written on the tag. We are working with 5 heavy metals here, which is cadmium, lead, nickel, chromium, arsenic. So each of those samples had already been bottled. It has been tagged, it has been labeled, so that the lab will be able to know that, oh, this particular sample, we are going to analyze chromium on it. This particular one, we are analyzing cadmium. For me, I am not looking for cadmium inside lead or lead inside cadmium. Each of those samples, I'm going to analyze each heavy metals from it. Of course, we are getting 25 mils of the filtrate, whereby if it's not up to 25 mils, we use distilled water to augment it so that it will be up to 25 mils for the AAS analysis. Thank you guys. God